Alright. So in this case study, we were at the analyze phase where we had to analyze what are those critical X's which are actually significant for us in the further analysis. So we've identified various inputs which are going to influence our output, which is connection activation time. Right, so what are those various inputs they have given to us? Though we have brainstormed and identified, they have also given correct title, incorrect title, correct name, incorrect name, correct email address, incorrect email address, right? ID proof matched, ID proof mismatched, correct reseller code, incorrect reseller code, correct residence address, incorrect residence address. Right, in this way you have many things. Correct date, incorrect date. These are all the various inputs which might go wrong in the customer application form. And people working in the shifts. Sometimes if people tend to work in night shift, they make some mistakes. Maybe. So you have collected the data based on shifts also, 3 shifts. So here primarily there are 2 tests we have to perform. Let me go back to this. So here again, once again, y is equal to f of x concept which is in. Y is equal to f of x. What happened? One second. Okay, my bad. All right, it is gone, thankfully. Okay, y is equal to f of x. So y is the connection activation time, which is influenced by various inputs which we have just seen. So what is y connection activation time? Is it continuous or discrete? Continuous. So y is continuous variable. Perfect. Now let me take you to the Minita file. Let us go to the first one. Correct title, incorrect title. Is this continuous or discrete? This is the activation time. You told y is continuous. I'm speaking about correct title, incorrect title. Yes or no kind of situations. Is it discrete or continuous? Yeah, Anuj, what do you think? Correct, no. Correct title, incorrect title, yes or no kind of scenarios clearly see that it is discrete data, not continuous data. Your name, right? For example, your title, Mr., Mrs. or Miss. It doesn't really, qualify for continuous data. Why is continuous? Why is your oh yes or no? Okay. Did they enter the correct title? What will you say? Oh, no. Against this correct title and correct title, they have provided the activation time. So activation time is y is equal to f of x, right? So these are the x's. Yeah, that is why they have given. So now, simple. If you go back to the table or the flowchart of hypothesis testing, if y is continuous and x is discrete in 2 categories, here there are 2 categories. If y is continuous and x is discrete in 2 categories, here also we have 2 categories. Here also we have 2 categories. Here also we have 2 categories, so on and so forth. Right? If y is continuous, x is discrete in 2 categories, you use 2 sample t-test. If you just go back to that flowchart and see, you will come to know about this. So in two sample t-test, the first thing is we check for the normality of the data. Is data normal or not? I simply go to stat, basic statistics, graphical summary. Let me select correct title and incorrect title. And then I'll simply click on OK. I just look into Anderson-Darling normality test p-value. It's 0.598. So what do you say, Anuj? Is data normal? Yeah, I just did the normality test. Data is normal for this, you agree. How about this correct title? Look at the p-value and comment whether it's normal or not. Yes. If data are normal, right, you go ahead and check whether variances are equal or not. First thing is check whether y is continuous, x is discrete. Yes. How many categories are there? Two categories. Correct title, incorrect title. There are only two categories. If there are two categories which are discrete and y is continuous, you do two sample t-test. But in two sample t-test, first thing to check is data normal or not? If the data is normal, the second thing is you check are variances equal or not. So I go to stat, basic statistics, two variance test. I click on that. So is a sample in one column or is a sample in two columns? Sample is in its own column, right? Correct title has its data, incorrect title has its data. So I selected both the samples. I just click on OK. Here I need to look into Bonnet's test. 0.410. So if P high, what will you select? Null hypothesis or alternative hypothesis? If P is greater than 0.05. Null hypothesis. So what is a null hypothesis for variances? Two variance test. What is the null hypothesis? Both the variances are equal. Oh, sorry, what did you type? Yeah, absolutely correct. Put in this way. Variance of correct title is equal to variance of incorrect title. This is your null hypothesis. And the opposite of this will be your alternate hypothesis. Alternate hypothesis will say both the variances are not equal. Simple. Job done. So in this way you have to compose your null and alternate hypothesis even before proceeding with the analysis. So we are done with this. Just a minute, Anuj. Okay. So um, yeah, no, sorry for that. So we are done with normality test and variance test. We found that variances are equal. If variances are equal, if you go back to the flowchart and check, we have to do two sample t-test assuming equal variances. Now what does that assuming equal variances mean? I'm going to explain just in a minute. So all you need to do now is go to stat, basic statistics, do a two sample t-test. You have selected that. Both samples are in one column? No. Both samples, each sample is in its own column. So correct title and incorrect title. Sorry, incorrect title. Now if I go to options, there is an option to select assume equal variances. So I need to select this assume equal variances if the variances are equal. Oh, Anuj, have you asked me to wait for a minute? Okay, yes, that's right. Two sample t-test as y is continuous and x is discrete. Correct. You are right on that. So now I just click on OK. I get the p-value here for the t-test also. Look at the p-value and say, Anuj, is it greater than 0.05? If it is greater than 0.05, then what will you select? Null hypothesis or alternative hypothesis? Null hypothesis. But what is null hypothesis here? What is the null hypothesis here? I mean, how will you write it? Null hypothesis will say mean of correct title is equal to mean of incorrect title. Alternative hypothesis says mean of correct title is not equal to mean of incorrect title. So now simply you're saying that go with null hypothesis. But what does that really mean? It means that the activation time taken when there is correct title or when there is incorrect title is the same. There is no difference. So will you consider this input as critical for your analysis? What are you expected to do? You are expected to reduce the activation time. But here you found that if there is a correct title or incorrect title, it is not mattering to the activation time. Activation time is still remaining the same for both, whether they provide you incorrect title or incorrect title. So what do you infer from this? What is the conclusion? Are you going to consider this input for further analysis or not? No, because there is no scope for improvement. Both are the same. If yes, if incorrect title was taking longer time than correct title, then I should have worried about this input and I should have taken corrective actions, right? So in all these cases, wherever there are two, incorrect name, correct email ID, ID proof matched, yes or no, right? Correct seller code, yes or no again. Correct address, did they provide correct address, yes or no? Did they provide correct date, yes or no? In all these cases, you use same thing, two sample t-test. But here it changes. There are three shifts. Shift is discrete. Activation time is continuous. So y is equal to f of x. Y is continuous activation time. X is discrete, which are shifts, number of shifts. But there are three shifts. There are not two categories. There are greater than two categories. And if y is continuous, x is discrete in more than two categories, you use what? ANOVA test. We do ANOVA test. Yeah, remember Anuj? So if by chance you do not remember, I would request you to, practice all the exercises once again, because this I think would remain the most important thing. Yeah, ANOVA test and all that. So we do what? ANOVA one way. Yeah, you remember, right? Good. So I was, why ANOVA? Okay. If y is continuous, y is what? Customer activation time. Activation time is y. These are the numbers. Y is continuous. If y is continuous, then we have to check what is x. X is shift. Morning shift, afternoon shift, night shift, or shift 1, shift 2, shift 3. Is this continuous or discrete? Number of shifts. Discrete. If y is continuous and x is discrete, and if you have greater than two categories, here how many categories we have? Three categories. Shift 1, 2, 3. Y is continuous, X discrete in more than two categories, you use ANOVA test. Here also same thing, go to stat. First thing is normality test. Stat, basic statistics, graphical summary. Select the three shifts here. Then click on OK. Check whether the data are normal or not. So what do you conclude, Anuj? For shift 3, is it normal? Are the data normal here? Yes, perfect. How about shift 2? By looking at AD normality test, Anderson-Darling normality test. Yes. And the third one is also normal, right? P-value is greater than 0.05. If everything is normal, then we go ahead with the next thing, that is test for equal variances. We test for equal variances. Just a minute, Anuj. So now we have to do equal variances test. So all we need to do is go to stat, go to ANOVA, test for equal variances. Response data are in one column for all the factors. No, response data are in separate column for each factor level. This is the right one. So let us select shift 1 till shift 3. Let me see whether any options have to be selected. Use test based on normal distribution. Yes, we have already proven that the data follows normal distribution. Hence, we are just selecting that option. That's it, nothing else. So let us click on OK and OK. So Bartlett's test p-value 0.239. By looking at this, can you tell me what test are you going to, or are you going to select null hypothesis or alternative hypothesis by looking at this p-value? Null hypothesis, absolutely. P high null fly, no doubts about that. Okay, null hypothesis. Null hypothesis says all variances are equal. Alternate hypothesis says not all variances are equal. Now, once again, when we have done two sample t-test, we have written in this way. Variances are equal, right? There we had only two categories. Here, since we have three categories, we are putting it in this way. Or you can say that variance of shift 1 is equal to variance of, okay, shift 2 is equal to variance of shift 3. You can probably represent in this way. If you have more than three categories, writing everything would look cumbersome. Hence, you can just put in English terms, all variances are equal. So you're telling me that all the variances are equal. If the variances are equal, then you go with ANOVA one way. Let us do that. Sorry, let me select the pointer. Okay. I go back to the sheet. I go to stat, ANOVA one way. Response data are in one column for all factors. No, they are in separate columns. So let me select shift 1 to this. Let me see whether there are any options to be selected. Not required. It's assuming equal variance. This is something that we have to select. Why assume equal variances? Because we have already done the variance test. It has told us that all the variances are same. We have gone ahead with null hypothesis there. Okay and okay. So let us go to the text and see what is it saying as. So what is the p-value saying here? It's telling it's 0.464. So what will you do, Anuj, if p-value is greater than 0.05? What are you going to select, alternative or null hypothesis? Null hypothesis. What does null hypothesis say? All means are equal. In two sample t-test, we have represented null hypothesis in this way. Right? Here, since we have greater than 2, we have put it in English terms, or you can also say null hypothesis is mean of first shift is equal to mean of second shift, which is equal to mean of third shift. Either represent in this way or that way, both mean the same. So finally, if all means are same, that means activation time is not varying depend on the shift that a person is working in. If this is a conclusion that you're arriving at, then do you say that shifts are significant for your analysis or insignificant? No matter in which shift a person works, the activation time is the same. Yes, absolutely. So it's not significant for you. You're going to leave away even the shift. Right? You'll not consider this as a critical input for you. So coming back to our exercise. So you just put wherever you the last test says that go ahead with alternate hypothesis. Those are the potential inputs that you're going to select. What test have we chosen? You know, we have done two sample t-test and ANOVA test. So you just mention the tests chosen and what are your inferences. Is that clear, Anuj? Yeah, perfect. So now improve. Whenever you're improving, first thing is we have to look into whether we can mistake proof something or not. For example, customer application form, maybe I can provide an online application to my salespeople who will come with their tablet to my home. Only if I enter the residence address, they'll be able to go to the next field. Only if I enter the identity proof number, they'll be able to submit the application online. If I put those kind of restrictions, it is kind of mistake proofing only. So what you have to do is first check whether you can mistake proof these critical inputs or not. But even before that, Ishikawa diagram will help you focus on the causes of these defects. These are the defects, residence address. But why is there a mistake for this residence address? Why are people forgetting or entering their residence address incorrectly? For this, you will brainstorm using Ishikawa diagram, that is fishbone diagram. And whatever causes you get, you try to address those causes using mistake proof. So try to mistake proof wherever possible. Mistake proof, if you do that, that is the best solution that you can provide to any problem. The moment it is mistake proof, that means no one can do mistakes even if they want to. So that is the beauty of mistake proofing. All right. So suppose you have done some mistake proofing and your some improvement has happened. What is that improvement? The project leader wants to ascertain whether any significant improvement has taken place by comparing sigma level before and after improvement. A randomly selected sample of 200 customer application forms is audited for defects and connection activation time. Is there any significant improvement or not? So what are the two CTQs that we have selected initially? One is activation time, another thing is percentage defects. We have calculated the ZST before using Sigma Excel. So let me see whether those values are still available here. Yeah, we have calculated ZST initially, right? Maybe I have not written it here, but we have opened sigma level calc. Oh, it's there, I believe. Good, it's there. So sigma level calculator, first thing is 2.64 for what? Activation time, connection activation time CTQ. The ZST was 2.64. But now, did it improve beyond 2.64 after the improvement or not? That is what we need to check. So for that, let me open this case study data post improvement. Okay, post improvement case study data is provided. I need to find out the mean or average of the processing time. So It is 30.02. Just remember that. Second thing is standard deviation. I want to find out the standard deviation of all these. So the standard deviation is 5.1. 30 and 5.1. Let me input these two in sigma level calculator. 30 and 5.1. Wow, it has improved from 2 point something to 5.03 ZST. Right, so I'll just put that information here. Before I started the project, it was 2 point something. Now it is 5 point something. So it's significant improvement. Next CTQ is percentage defects reduction, right? I need to check what was ZST before. Discrete data. ZST was 2.21 last time when we have checked. That is what we have arrived at. Now what are they telling? They are sampling 200 custom application forms are audited. Okay. So 200 is a sample. OFE is 7. Where did I get OFE 7 from? Let me go to the start. Title and gender of the customer 1 OFE, name of the customer 2, address is 3, 4, 5, 6, 7. There are 7 OFEs here. Yeah, this is how I got 7 OFE. If you do not follow anywhere, let me know. So I need to check the number of defects now. Simple. Let me do the sum of defects. What is the count? 1 or 2. So let me put 1 or 2 defects here. Sigma level increased significantly. It was 1 point something, now it is 2.95, which is a good improvement. Though it's not even touching your 3 sigma level, it's a good improvement. So those things you mention here and then you move on. Yeah, this is what you do, right? Now the second thing is the project leader wants to compare mean connection activation time before and after and defect percentage before and after using the appropriate hypothesis test. A randomly selected sample of 200 customer application forms is audited for defects and connection activation time. Is there any significant improvement? So when we have done the hypothesis testing, we should have noted down all the p-values. Now we perform another hypothesis testing after the improvement, and then we compare those p-values. Did the p-value really increase or not? Really improve or not? For that, you can just open master data sheet, or let me see whether there is. Let's see. Post improvement master data minitab file. Is it opening up? Yeah, it's still opening up. So let us see here while that opens. Post improvement master data. Just bear with me. Correction activation time and that. I need to take before versus after basically. So what I have to do is here. This is the process. My audio is lost. Which screen are you seeing now? Spreadsheet processing team. Yeah, I'm on that screen only. I haven't moved actually. Since I got that message that audio was lost, I just So are you able to see this processing time? So what I have to do is simply, this is processing time post improvement, right? I copy this, I go to the Minitab file. Wow, excellent. Oh my God. I think connection connection was lost once again. Anuj, please confirm on whether you are able to hear me or not. You're able to hear me, right? So what they are asking here is, check whether before versus after there is any improvement or not. So I've just put the processing time here after data. Before data I'm pulling from this one. Let me copy it. Let me put in this processing time before. Processing time before and after. I need to compare these two and say whether there has been significant improvement, yes or no. What test am I going to conduct here, Anuj? This is continuous. Activation time is continuous. But before and after is discrete. Before, after, I cannot have anything in between. 50% before, 20% after. I cannot have that kind of segregation. Hence, I classify that as discrete. So if Y is continuous and X is discrete in two categories, what test are you going to follow? Two sample t-test. For two sample t-test, the first thing is check whether the data are normal or not. Right. So what do you conclude, Anuj, here by looking at the p-value? Is the data normal? Yes, perfect. What do you conclude from here? Is the p-value greater than 0.05? Yes. So it's normal once again. If data are normal, you go ahead with variance test. Stat, basic statistics, two variance test. Both samples are in one column. No, they are in their own column actually. So processing time before, after I select, click on options, not required, click OK. I get p-value. Now tell me, Anuj, is p-value greater than 0.05? So which hypothesis are you going to select? Null hypothesis or alternative hypothesis? Alternative hypothesis. Alternative hypothesis says variances are not equal. So if variances are not equal, then the test that you're going to perform would have slight change. Let me show you that. You do two sample t-test only. Both samples, each sample is in its own column. You select that, click on options. Assume equal variances is when variances are equal. Now we selected alternative hypothesis. It says variances are not equal. So you're not going to put a tick mark beside this. That's it. Okay and okay. You get p-value. Interesting. P-value 0.000. What does that mean? What test are you going to, what hypothesis are you going to select? Alternative hypothesis. So if null hypothesis says that processing time both before and after are the same, your alternative hypothesis will say processing time before and after are different. Null hypothesis says both are same. Alternate hypothesis says both are different. Absolutely, that is what we want to conclude, right? There has been a significant improvement from processing time before and after. If there is a significant improvement, right? If there is a significant improvement, that means both the means should be different. And that is what is happening here. So you mentioned that p-value is 0. What is the inference? You'll say that yes, after improvement, there is a significant change in the mean. Right, Anuj? Similarly, for number of defects also, you perform that. Now we move on to the control chart. The project leader wants to continuously monitor Y. What is Y? Your customer activation time. He wants to monitor. And also one of the X's that they could not completely mistake proof. Therefore, it was decided to control chart them. Please use the appropriate control chart and draw the inferences. Y is your activation. One is your customer activation. Another thing is percentage defects. What is the data type? Is it continuous for activation time? Is activation time continuous, Anuj? You with me? Yes, it is continuous. For continuous data, if the subgroup size is 1, means I'm getting the details from one call center, basically. Then you use IMR chart. Next Y2 is percentage defects. Percentage defects. Is it continuous or discrete? Defects. Discrete. If you go to that control chart's flow chart in your control phase document, you will see that if it's defects and if the sample size is fixed, basically, then you go with C chart. Okay, so let me open this post improvement control chart mini tab file. We'll just do it quickly. Should not take much time. We'll do IMR and this. In that way, you also look at one critical input. They would have given in that mini tab file itself on what is that one input X which they could not mistake proof. If you cannot mistake proof, you have to somehow monitor it, either by doing audits or using control chart something. Control chart is the next best thing. If you cannot mistake proof it, then the next best thing is you use control chart. Is it open? Yep, it's open now. Oh, subgroup size is given as 10. If subgroup size is 10, sorry, my bad, then it's not IMR chart, it is X bar S chart for this processing time. So let us do that. Stat, control charts, you go with, for subgroups, because we have subgroup size as 10, right? It is X bar S. All observations for the chart are in one column. Yes, they are only in processing time column. What is the subgroup size? It is 10. I click on X bar S, click on tests. I want to select all the tests and OK. So you see that everything is pretty much in control. But even if we look into all that 8 tests, then I move on. Second Y is my number of defects. As we know, if I have number of defects and the sample size is fixed, 10, 10, 10 invoices everywhere, right? Why we select X bar as? Okay, perfect. So if Y is continuous, if you go to that control chart table, it will say that Y is continuous, processing time is continuous, and they have given sample size or subgroup size as 10. If Y is continuous and subgroup size is 10, you go with X bar S. If the subgroup size is only 1 instead of 10, then you go with IMR chart. Right? So in that way. So number of defects are given and invoices are 10. So sample size is fixed, number of defects is given. In such scenarios, you go with C chart. I'm going to the control charts, attribute charts, plot the C chart, number of defects, it's in C9. I want to select all the tests. Let me select everything. Okay and okay. Now look at the C chart. There is no outlier here also. Everything is within the control limits. Hence you conclude that everything is hunky-dory. Now let us look at the X. They're telling number of invoices. Residence address incorrect, right? Residence address incorrect. Out of 15, 2 are incorrect. Incorrect means it is a defect. Right? Or is this a classification or count? Defect, residence address incorrect, yes or no? It's a classification. You're classifying whether it's correct or wrong. You're not counting, right, basically. So it's number of defectives. And is a variable, is a sample size fixed or variable? If I see first time I've checked 15 invoices, next 20, next 11, 12, 14, 20, it's variable. It's not fixed. Here it is fixed, 10 continuously. Here the sample size is varying. If the sample size varying and if we are dealing with defectives, then we do P chart. Then we go ahead with P chart. So let me go to the attribute chart and P chart. I just select the residence address incorrect. Sample or subgroup size. What is a subgroup size? Day number. Now let me select the P chart options. Test. Let me select everything and okay. Got it. I was expecting this. One second. It is. Yep. Now I got it. So by looking at this, can you conclude, Anuj? Is there any outlier? No. So you conclude that when I was monitoring, everything was okay. So you as a Six Sigma consultant should also set up these control charts for those folks to actually continuously monitor their process. And after control phase, what do? You get a formal sign off from the key stakeholders that you have concluded the project. Everything is good. You have shown them post improvements also, and then you come out of the project. So with this, we come to